Welcome back, everyone. Let's take a look at a couple of other things in Matlab. The first thing we want to talk about are variable names. You may recall in a previous video I had something like Fred is equal to 5. And so you can see that that is a variable up here now in the workspace. But what about names that are already being used? Got to be really careful with that because things like pi have already been used. And you don't want to reassign them because I can, in fact, reassign the value of pi. I could say pi is equal to 5. And now it's equal to 5. And if I take 3 times pi, I get 15. And if I take the sine of pi over 6, that should be 1/2, but it isn't because pi is no longer 3.1416. So I would have to clear my variable space in order to get back that value for pi. So now pi is back to that. So the sine of pi over 6 will equal 1/2, which is what it should be. So a couple of different variables that you should not use. A and S, you already know that that's for answer. The date, that's also a built-in variable. And the time, or the clock, it's what it's called, that's in there as well. INF, that's infinity. Pi, we've already talked about. 2 more that are important would be I and J, because I is the square root of -1. And so what you're seeing here is the complex number 0 plus 1i, where, again, I is the square root of -1. Here you see the same thing, but I typed in J, and that's because in electrical engineering, I is used for current, but we do use complex numbers in electrical engineering quite often. So we've assigned the value or the letter J to the square root of -1. So you want to be careful of that reassignment and those other things. Now, what about sine? Could I say sine is equal to 4? I can, but then, what about the function sine? So I've got to be a little careful about that. So if you're interested in whether or not a function name is legal, you can do a command called which. And what that does is it says, well, which sine, and it tells me that's no longer a function. Now it's a variable name. But if I said which cosine, that would still work, right? So by assigning sin equal to 4, I've eliminated sine from my function possibilities. So let's clear the variables out and then do which sine, and you can see now it's back to being a built-in function. What about Josiah? You'll see that that's a function, and you can see it actually up in here. There's Josiah.m, and that little icon tells you that that's a function that Josiah created in Matlab. So that's a built-in function and should not be used as a variable. If I use it as a variable, then I lose the function Josiah, should I choose to call that out at some point in time. I could do another thing, is var name. This is going to find out whether or not it's a legal variable name. And I might say something like body 8. And looks like that's okay. Answer equals 1 means it's true. That's a good one. But if I said is var name 8 body, you'll see that that gets a 0, and that's because it's false. You cannot start a variable name with a number. They have to start with a letter. Okay, so you want to be careful about that. And remember that this is all very much dependent on upper and lower case. So the case of that will matter. Okay, since I've already talked about sine, let's talk about trig functions a little bit. We've already seen that the sine of pi over 6, oops, that's not a 6, pi over 6 is 1/2. And so sine assumes an argument of radians. If I want to use degrees, there is another function called sine d for degrees, and I can type in 30, and you can see I get 0.5 in there. Okay, and then if I wanted to know the arc sine of 0.5, I do a sine, and that's 0.5236. And if I take a and s times 6, you'll see that that's pi. Right, so it gives me a rounded off value when I do the arc sign. There's one other trigonometric function you may come across at some point in time, and that's the hyperbolic sign. And so I'll do sine h, and that means the hyperbolic sign of pi over 6. And it's a little different than the sine, and so you can see I don't get 0.5. But if you ever come across hyperbolic functions, then you know Matlab can handle those. Okay, I want to talk a little bit about vectors. In Matlab, a vector is any matrix that's just one row. So for example, I could say Bob is equal to, now remember that matrices start with a square bracket, 1, 2, 3, 4, 5, 6. Oops. And then close that off. And you can see Bob is now a variable, and it's 1 through 6. So that's one row, 6 column matrix, but MATLAB considers those vectors. What we want to think about as vectors would only have 3 columns. So if I wanted to say that force was equal to 2, 4, 6, that would be a vector for force. And then maybe radius might equal another 3-dimensional vector. Let's say -1, 5, 2. So I can put that in there, and there I have 2 vectors. Now, in MATLAB, multiplication is fairly specific, and we'll get into more detail on that in a little bit. But what I want to talk about is how do I multiply these 2 vectors? Well, we know in physics that moment, or torque, is radius cross product with force. So how do I do a cross product? Well, I'm not sure. So what I want to do is I want to go up here to search the documentation. I'm in the upper right corner, and I'm going to type in cross product. And when I do that, this window pops up, and it's got all sorts of information about cross product. And if I type or push on cross here, it says the cross product of 2 vectors. I just use cross and then the names of the 2 vectors. Let's not worry about dimension. If I scroll down a little bit, you'll see there's some other information about dot product. Kind of see that here, and that takes the dot product of 2 vectors. So let's give that a try. So let me say that torque equals the cross product of radius and force. That's not right. I typed that correctly. And there's the cross product between the radius and the force. Work, on the other hand, is the dot product between force and distance. So let's say that work equals dot radius. We'll say that's the same as distance and force. And you can see that just returns a number. Torque returned a scalar, and you'll see torque up here. Excuse me, torque returned a vector, but work returned a scalar quantity. All right, so there we have some cross products and dot products for what we'll consider to be vectors in the engineering world. So just think about that as 3D vectors. So we can still do 3D vectors, cross products, and dot products. Of course, we can add vectors. I could take nothing and set it equal to radius plus force. And I say nothing because you can't add 2 vectors that aren't the same dimension. We'll get into that. Not dimension, I mean units. Okay, so let's not talk about that too much. But I can add those together, and I can subtract them. Nothing else equals radius minus force. Try to multiply them, radius times force. I'm not going to get a nice result there, right? Because I can't multiply those 2 vectors. It's because of times. The times key is not a dot product. It's not a cross product. That's trying to multiply those together. All right, so we'll get into multiplying these vectors and matrices in a later video, but I want to get you started on some of that information right here. All right, I think I'll stop there. If you have any questions, please leave them in the comments below. Thank you.